Hi guys. So today we're going to be starting off with our first session for IGCSE and O-level maths. All right, we're going to be starting off with the very first chapter, that is numbers. And throughout this video, we're going to be talking about the different types of numbers that we have, like natural numbers, whole numbers, integers, real numbers, even, odd, and so on and so forth. Okay. Apart from that, we're also going to be talking about your HCF and your LCM, which is your highest common factor, and your lowest common multiple. Okay, to start off, we're going to talk about your natural numbers. Okay, so what exactly are natural numbers? Natural numbers would be those numbers which we use on an everyday basis to count stuff, to count anything, as a matter of fact, right? So, and for example, we can list down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, and the list goes on. All right. So these are the numbers that you would normally use in your everyday life for counting purposes. All right. Let me quickly write down the definition for you to note down in your notebooks. Just a second. All right. So that's the definition we have for your natural numbers, right? I mean, you don't really have to go verbatim or memorize it, but it's just for your your aid, your assistance, so that whenever you are going through your notes, you can just recall what exactly we talked about in the class. All right, next up we have your whole numbers. I'm sure a lot of you already know what whole numbers are, but I'm going to go through it anyways. So whole numbers. So whole numbers are basically all your natural numbers, including zero. All right. So the natural numbers, it does not have zero in it. All right. But when we're talking about your whole numbers, we do have zero in them. All right. So it's basically the same set, but it has zero in it. Let me quickly write down the definition here. All right. So whole numbers are natural numbers which include the number zero. Natural numbers are all the numbers that you would normally use to count stuff, all the way up from 1 to infinity. All right. So now we're going to talk about integers. What are integers? Integers are numbers that can be written down without a fractional component, or without being in fractions. Right? These include your negative numbers, your positive numbers, zero, all of them. Right? So for example, I'm going to list them down for you guys. Let's see. We can have -4, 3, 2, -1, 0, 1, 2, 3, 4, 5, and so on. The list goes on. Right? So that's your integers. All right. For integers would be, it's a very small definition, so I'm just going to write it down. Number that can be written without a fractional component. There you go. All right. Next up, we have rational numbers. Rational numbers. All right. So rational numbers are basically written down in the form of fractions, right? And these are those fractions which are which can be easily expressed as decimals. All right. So what do I mean by that? Let's suppose, for example, we have 1/2. We have 3/4. So 1/2, if written down in fractions or expressed in fractions, is 0.5. 3/4, when expressed as decimals, would be 0.75. There you go. So it's easier for us to write them down or list them down in fractions. Similarly, let's suppose if we talk about I'm going to list down the definitions for them later on. So let's suppose we have irrational numbers. All right. So irrational numbers are those numbers which cannot be easily expressed as decimals. All right. So for example, let's suppose, we have under root 5, right? We have under root 5. We have 10 upon 3, right? So if I was to write them down as decimal, so under root 5 would be something like 2 point, I don't know, 2360679, and goes on, right? Same thing goes for 10 upon 3. If I wanted to write this down in decimals, it would have been so 3.33333, something like that. Goes on. Right? So it's a never ending thing. Right? It's gonna keep on recurring. Okay, it won't stop. So it's not easy for us to write down irrational numbers or such numbers as decimals, right? So such numbers or such types of numbers are called irrational numbers. All right, let me quickly write down their definitions for you guys. Just a second. All right. So that's about rational numbers and irrational numbers. I'm sure you know what the difference is now. Next up, we have real numbers. All right. So real numbers are basically, it's a union. It's like it's a combination, or it consists of. Let me write it down. So we have real numbers. So real numbers basically consist of all natural numbers, all natural numbers, all decimals, all fractions, all the decimals, all the fractions, right? And it contains all the rational numbers. It contains all irrational numbers as well, right? So yeah, that's basically what your real numbers are. All right. Next up, we have odd numbers. All right. So I mean, we don't really. I wouldn't really have a proper definition for this. There's a much easier way to remember these odd numbers and even numbers, right? So let's suppose we have odd numbers, we have even numbers, right? So when it comes to even numbers are basically those numbers which are easily, it's easy for them to be categorized into groups of two, right? So let's suppose we have 4. We can divide them into 2 and 2. Let's suppose we have 6. You can divide these into 3 and 3. You have the number 2 itself, and divide that into 2 groups of 1, right? It's easier for you to categorize your even numbers or these numbers into 2 groups. Similarly, when we talk about odd numbers, it's different. You cannot categorize them into groups of 2, right? I mean, yeah, if you think about it, you can just divide them into 1.5 or 1.5, but once again, they're not going to be whole numbers, right? You need to divide them into a whole number kind of category, right? So 3, and you have 5, right? There's once again 2.5 and 2.5. You have 7, 3.5, 3.5. All right. So these, it's not possible for you to divide them into groups of 2 or groups of 2 whole number, basically. Okay, so there's another method that we have here for, you know, to differentiate between an even number and an odd number, that is divisibility. Okay, so for all even numbers, please note that they are divisible by the number 2. And by divisible, I mean completely divisible. Okay, so let's suppose if we have the number 2, we have the number 4, 8, 6, 10, 12, 14, whatever these numbers are, you need to note that whenever you divide these numbers with the number 2, you will always get a complete or a whole number as the answer. Okay, but whenever you're dividing an even number, whenever you're dividing an odd number, right, you will note that you're not getting a whole number as the answer. You'll probably get your answers in fractions, or you'll probably get them in decimals. Okay, so let's suppose we have 3, you divide 3 by 2, you get 1.5 or 3 upon 2. You divide 5 by 2, you get 5 over 2 or 2.5. However, once again, if you divide an even number by 2, let's say 4, you will always end up with a whole number, which is 2. Let's suppose you divide 8 with 2, you get 4. You divide 12 with 2, you get 6. See? So that's a very, it's a small tip that you should remember, that, you can also divide a certain number with the number 2. And if the answer is a whole number, that means the number is an even number. Okay, right? So that's even numbers and that's odd numbers. Pretty basic. I'm sure you know all of these things. So yeah, that's it about odd numbers and even numbers. Next up, we have prime numbers. I'm sure you guys already know what prime numbers are. We're gonna go through it anyways. So prime numbers. Let's see. Okay. So prime numbers. Prime number is basically the number which is only divisible by itself and the number 1. All right. Only divisible by itself and divisible by the number 1. Let's go over a few examples. So let's suppose, what is this? All right, so let's suppose we have the number 2. 2 is divisible by the number 2, which is itself, and the number 1. However, 2 would be a prime number. Similarly, if we have the number 4, you can divide 4 with the number itself, 4. You can divide it with 2. You can divide it with 1. All right, so it does not meet these two conditions. All right, so these two conditions are not met, which is why 4 would not be a prime number. Okay, so similarly, we can go on. We have 2, 3, 5, 7, then you have 11, and so on. Right, these are the prime numbers. Why are they prime numbers? Because they're only divisible by themselves, by the number itself and the number 1. Right, which means that they do not come in any other table of any other number. Right, so 5 would not come under any other table except for its own and the number 1. Right, similarly, we have the number 10. Right, why is 10 not a prime number? It comes in the table of 2, comes in the table of 5, it comes in its own table, it's coming in the table of 1. Right, so that's why we're not going to include 10 in the list of prime numbers. All right, next up we have square numbers and cube numbers. These are basically the result or the product of the numbers which have been multiplied with themselves 2 times or 3 times. All right, so for square numbers, let's write down. So square numbers, right? So example, I'm going to write them down for you first. So example would be, let's see, for square numbers, the example would be 1, 4, 9, 16, 25, and so on. All right, so what does this mean? It means that when you multiply 1 and 1, you get this. When you multiply 2 and 2, you get 4. Multiply 3 and 3, get 9. Similarly, 4 and 4, you get 16. 5 and 5, you get 25 again. There you go. All right. So the product of these that you can see here, right? These are basically your square numbers. So whenever you multiply a certain number by itself and the number or the answer that you get, that's basically going to be your square number. All right. You often write them down as like this. So 2 square would be 4. 3 square would be 9. Right. Similarly, when we're talking about cube numbers, it's the exact same thing. All right. Cube number, the numbers which have been multiplied by themselves 3 times. Right. So list down a few examples. You have 1, you have 8, you have 27. So yeah, so on. All right. So when you multiply 1 with 1 with 1 3 times, you get 1. You multiply 2 with 2 with 2, you get 8. Right. Similarly, when you multiply 3 with 3 with 3, you get 27. 3 3s are 9, and 3s are 27. All right, fair enough. So that's why we call these numbers, or we call these numbers as cube numbers. All right, we represent or we write them down as this, like this. There you go. All right, guys, so that's it for today's video. We're going to be going through a lot of exciting stuff in the future. Right, so yeah, do give the video a thumbs up and subscribe to the channel if you feel like these videos are helpful to you, and I will see you guys in the next one. Take care, guys. Bye bye.